I hope you are done with the examples, cases and quizzes sections provided in Unit 4. And further, all your queries are answered. Now let's get going with multi-threading. Multi-threading. Real-life coding requires the developers to provide concurrency in their tools. That is, the illusion that two or more tasks are being performed in parallel. For example, a Microsoft Word application runs spell check, grammar check, and autosave even when you are editing the document. Here, spell check, grammar check, and autosave are all running inside the same application concurrently. Concurrency is provided by an operating system. It is the operating system which provides the support for concurrent task execution. A thread refers to a lightweight process. It is a part of a larger process and hence requires fewer resources. As you might have studied in your operating system course, threads share the same address space of that of the process and hence require fewer resources when compared to a child process. A thread has its own set of PCB. As discussed, if you want to develop a threaded application, the operating system should provide you a PCB for every thread created. Further, I would like to add that JVM works only on multi-threaded operating systems. For example, if you directly boot to a DOS operating system and run the Java command, it does not support. Java has excellent support for developing multi-threaded applications. You will soon see the Java multi-threaded API in action. A developer can implement threads in his or her application without being aware of the lower level implementation details. The Java Thread API hides the low level implementation that makes it convenient for the developer to develop the thread applications. Java supports multi-threading by means of runnable interface and thread class. Creating a thread by implementing the runnable interface. Here is an example. Class myThreadClass implements runnable. Keep the code to be executed by the thread in void run. Public void run is the method from where a thread execution begins. Create an object of the thread class and pass a runnable object to its constructor, as you see here in this example. Thread myThread is equal to new thread new myThreadClass, where new of myThreadClass is a runnable object. And then invoke the start method. Now let's look at an example. In this example, I have the class myThreadClass which implements the runnable interface. The runnable interface defines a method public void run, which is required to be overridden, as you see here in this code. Further, I am creating an object of class thread at line number 12 and passing the myThread class or the runnable object to the constructor of the thread class. And then we're calling the thread object.start method. The start method internally invokes the run method, and then the code in the run method automatically starts executing. You may find this example in the Java Virtual Guru. Please try the same. Creating a thread by extending the thread class. Extend your class with thread class. As you see here, class myThread class extends class thread. Having extended the class thread, you need to override the run method. As discussed earlier, the method run acts as a point from where the thread execution begins. Further, create an object of your class, saying myThread class myThread is equal to new myThread class. Here, you need not pass a runnable object. Invoke the inherited start method by saying myThread.start. Now let's look at an example. In this example, I have the class myThread class which extends the thread class. And then here is my public void run which has been overridden. Further, I have created the object of myThread class here at line 12. I need not pass a runnable object to my class. And further, I call the start method, which initializes the thread and further calls the run method. Now let's look at another example. In this example, I have a class myThread which implements the runnable interface, and then the class main. Here I have created the implementation for the run method, where I am printing a message myThread and the value of I. And then in class main, I have created an object of myThread, passing the same as a parameter to the thread constructor. Further, I am calling the thread object.start method, which in turn calls the run method. And then the main method also has a for loop printing a message main thread and the value of I. Now let's execute this example. Here is the output. If you have noticed, the main thread started first and then the control has moved to the myThread. And further, the main thread is back in action. However, the output of a thread application cannot be predicted. You may try out this example. When two threads are running, the output cannot be predicted. Each thread works independently. Now let's discuss about daemon threads. You might have read about daemon processes. Daemon process is a process which runs on the background. For example, your printer process is a daemon process. The daemon processes are processes running on the background and may serve the foreground processes. And similarly, you have daemon threads. Threads that work in the background to support the runtime environment are called daemon threads. For example, the clock handler thread, the idle thread, the garbage collector thread, the screen updater thread, etc. are daemon threads. By default, a thread is not a daemon thread. Set daemon true turns a thread into a daemon thread. setDemon is a final method. You cannot override the same.